Hello, everybody. I want to take you through the exponential assessment solutions. This will be a key part of what you'll need to focus on if you choose to reassess a certain section. So, without further ado, let's take a look at the first page. So, the first page was the multiple choice, determining which is identified by either the given statement, graph, equation, or table. So if I am doubling the grains of rice, I am multiplying by 2 every time. As I'm multiplying by every 2, I have a constant multiplier. Doubling is 2, so that is greater than 1. So it is going to be exponential growth. Should be your right answer. The second one, I'm losing half the amount each day. So I'm going down by 1/2, multiplying a half each day. So again, a constant multiplier, so it's exponential. And because I'm losing, is it going to be exponential k, as indicated by the green mark. Third one, I'm increasing by 20%. So that percent is a rate. So I'm exponentially increasing. Increasing refers to growth. So this is an exponential growth situation. So which of these equations, A, B, C, or D, refers to exponential growth? Well, it cannot be A because that is a linear equation. B, C, and D are all exponential. So I need a constant multiplier that is greater than 1. And B, 1 minus 0.25 will give me 0.75. Just the same as D. Both of those are less than 1, so that would be K. So the only one that can create growth is equation C. The next equation, y equals 2x plus 1.10, is in y equals mx plus b form. That is a linear equation. In the table, I am not increasing at a constant rate. 6, 12, 24, so it cannot be linear. Is there a constant multiplier? Multiply by 2, multiply by 2, multiply by 2. I do have a constant multiplier, so it's exponential. 2 being greater than 1 means I have an exponential growth situation. This graph shows a line, not a curve, therefore it's not exponential or other. It has to be linear if it's a line. The next graph does show a curve, an exponential curve. From left to right, the curve is going down, so it is decaying. The numbers are getting smaller. That's not the exponential decay. And the last one, salary increase of 3,000 per year. So every year I'm getting $3,000, same amount. So that is a constant rate of change, which means it is linear. And that is the end of section 1. All right, so moving on to problem number 2. Mr. Bolio is hosting a tennis tournament with 64 players. Each round, half are eliminated. So we have to complete the table first. So if I'm losing half, I'm multiplying by a half. Half of 64 is 32. Half of 32 would be 16. Half of 16 would be 8. Half of 8 would be 4. So that is a completed table. My equation is y equals a times b x with the numbers for this equation. A is my starting amount. I start with 64 players. B is my constant multiplier. half of the players are being eliminated. And then I'm raising that to an exponent of x. Some of you put a number. In fact, the question specifically says for each round x. So it should have had no number in that exponent. I then had to graph. And if you got a 3.5 or 3, did you label your axis and provide an accurate scale? So on the bottom is number of rounds. And the y-axis is the number of players. And so I have to provide an accurate scale for each box. I can't just put in the number of people. But I'm going to go by 5. Each box is worth 5. And I'm going to use every 2 boxes as a round. 1 round, 2, 3, 4, 5. And finally 6. And so at 0 rounds, I had 64 players. After 1 round, I had 32. After 2 rounds, I had 16. 16. After 3 rounds, I had 8. After 4 rounds, I had 4. So that would be the graph. And now to figure out how many rounds it would take for a player to win the tournament. Could have done it a couple ways. I could have continued my graph. So I'm down to 1 player. So after 5 rounds, I have 2. After 6 rounds, I have 1 player left. So 6. Let's undo that. So 6 rounds total. The other way to do it would be to continue the table. So after 4 rounds, we had 4 people left. After 5 rounds, we'd have 2 people left. They would have to play a 6th round to determine the winner. So graph or table would be the way to get there. You could have done trial and error with the equation, but either way, it will take a player 6 rounds or 6 games to win the tournament. Moving on to the last problem, cell phones. So in 92, we started with 600 cell phone users, and they are increasing by the same percentage every year. Don't consider the fractional people. So the first thing I need to do is to write an equation. So again, exponential equals a times b to the x. My starting amount is 600 people. I need a constant multiplier. So in order to do that, I take the second number divided by the prior number. When I put that in a calculator, I get 1.7. And I'm going to double check and make sure it's constant. I get 1.7. 8, divided by 1634. Again, is 1.7. So I have a constant multiplier of 1.7. And again, I'm looking for those in the year X. So my exponent will be X. That is the formula I'm looking for A. For part B, I have to determine the growth rate. I know my growth factor is 1.7, and that is equivalent to 1 plus the rate. So if I break that down, that's 1 plus 0.7. So 0.7 as a percentage is 70%. So that is the growth rate, 70%. Part C, I'm using my equation to figure out how many cell phones or people have cell phones in 2000. So started in 1992, so it's been 11 years. So I'm going to raise it to the 11th power. If you had a different equation and put in 11 for x in your equation and got the right answer, you got credit here. But if you put in this equation, you should end up with 205,631 people. And finally, if they grew at a faster growth rate, 90%, what would you have to change? A lot of answers I took here. You would have to change constant multiplier. The 1.7 will become 1.9. 70% would have to become 90%. The B value would have to change. The growth factor would have to change. So anything along those lines, I accept it as a correct answer of what you would need to change in part A to reflect a different growth rate. So just to break down what went into each competency, the distinguished competency was made up of that page 1 multiple choice. The create and build competency was based on the table, graph, and equation from problem 2 and the equation from problem 3, as that is all stuff that you had to create and build. The evaluate was the number of rounds from problem 2 and the number of people from problem 3, as those are the things you had to solve. And your analyze came from problem 3, part B, the growth factor, and part B, change 90%, what would change in equation from A. So those are the 4 parts, 4 competencies, and what each one was made up of. If you choose to reassess, make sure you understand which questions you are reassessing. Thank you very much.